Hello, my name is Matthew. I'm an application engineer here at Hawk Ridge Systems. This video is the part 2 to our Ray video series, which will go over the processing of Ray data and getting a final output mesh to bring into other softwares. We'll be using a train for our example. Inside of Artec Studio, I've imported in our Ray scans by going into the file Import Mesh, then selecting on our Ray.c3d files in the SD card. You can select on multiple Ray scans if you'd like to bring them all in at once, or individually if you want to verify each scan one at a time. With our data in the software, I can erase the background information such as these trees and parts of the sidewalk, leaving just the data I want to align left. In the Align tab, we can align our various scans just like anything else inside of Artec Studio. The Ray, however, isn't based off of several frames, and it's just a single set of data. This means that it's similar to a mesh-to-mesh alignment. As such, you may need to select more points at a wider range across the data to get a proper alignment. Additionally, it's best to move the two scans closer to one another before clicking Align. Not doing these steps may result in a fine alignment to fail and lock the scan in an improper position. This may be corrected within the global registration tool, but we want to get the scans as close as possible within the Align step to ensure that the registration does work well. If the registration fails, you can always undo it and select more points, or even reposition the scan in a better way to make the alignment snap together easier. After an alignment, I typically will double-click the scan's name again inside of our list to unregister it. This lets me see how well the two scans blend together. We're looking for a very sandy surface with the two scans overlaid with one another. With our scans aligned, we can run a global registration to ensure all the data is aligned as best as possible. We have a few different options on how the alignment will run. If you have targets placed around the objects, you can use the target-based alignment, which is the most accurate form of registration. This at times can even bypass the manual alignment step if you have enough data and targets. Non-target geometry alignment is good to use when you only have 2 or 3 scans, since it looks at surrounding data in each of the scans to form its alignment. Geometry Ray acts as a final best fit though, and can be run before or after other forms of alignment. For this set of data, since the manual alignment went so well, I can run just the Geometry Ray option, which gives us a sufficient final alignment. To create our mesh, we can use the Sharp Fusion option. However, it's not really recommended for Ray data that is a fairly large size. Sharp Fusion is a very intensive process, and most computers can't handle it for data that the Ray typically captures. Instead, we will use Ray Triangulation, found at the bottom of our tools list. This will process each Ray scan individually, factoring the surrounding data, making a new mesh per scan, which we can export all at once to merge them all together. The two modes in here, Simple and Adaptive, dictate the final size and quality of the polygons. Simple will create a mesh and run a decimation process automatically. The higher the level of decimation, the lower the quality of mesh will be. Adaptive creates a mesh based off of desired edge length, so the smaller this option is, the higher quality our mesh will be. The rest of the settings pertain to how much the mesh will filter out sharp angled triangles and noise, which I'll talk about in just a moment. Clicking Apply will load the scans fully into Artec and begin making the mesh, which is a fairly quick process to complete. I prefer to take all of these newly made meshes and make them into a single color so I can see how well the final mesh will turn out. We can see in some parts of this new mesh that there are larger triangles from points matching with areas too far away from it. This is where those incidence angle filters come in handy. We can raise or lower them to ensure our data matches to a proper point. I've gone through and made a new version of the mesh with slightly adjusted settings to remove all of these larger polygons. If we click a mesh, we can go into its properties and see the amount of polygons making it. Since we will be combining all of the data together when exporting, our final mesh will be a combination of all 4 meshes' polygons. If each mesh already has 20 million triangles, our final mesh is going to be several gigs of data, which we don't want. In the Tools tab, I can run a fast mesh simplification on the individual scans, so they're at a reasonable size when we export it all together. Like most mesh data, we can reduce this by a large percent and not see a change in data, so I'm going to bring everything down to about 5 million triangles. Before exporting this mesh, I can change my render mode so I can see internal areas and if there are any infolded spots. Switching the back face to coal will remove the darker faces that we don't have any data on, letting us see through them and not anything inside. This is very handy for scanning buildings since we can remove the walls and see into the internal spaces much easier. The show option will let us see the faces of these darker areas from the back side, which is handy to ensure that there's nothing else hidden behind them. For infolded faces, we can also use the X-ray render mode. This will apply a transparent effect on all of our mesh data with an adjustable light setting. Areas of high creases or layers that might be folded in appear brighter, which can help pinpoint areas that the mesh isn't uniform between the various scans. Before I export the complete mesh, I want to add another set of data at a higher quality on the complex sections of this train. I've imported in some LEO data, and now I need to align this to the existing data and create a new mesh. The LEO data is of higher level of quality than the Ray. We can still align it to our existing scans due to the overlapping amount of information. In the Align tab, I'm going to register the Ray data first, then align the LEO based on a few points like a normal alignment. Again, I can unregister the LEO data to see how well they align between one another. In the Tools tab, I can switch the processing mode to LEO so global registration and infusion commands run properly. If I change to the display mode to color instead of scan, we can see that the Ray data appears in black and white due to me not scanning in a color mode. This train happens to also be a darker color, so even the LEO doesn't have much color data to work with. After locking the Ray meshes in place via the right-click menu, I can run a global registration with geometry only for the LEO scans, aligning our LEO frames with the surrounding meshes. After running global registration, I'll hide the Ray mesh data to run the fusion process on the LEO scans only. Once finished, we can see how well the two meshes aligned with one another. With all the meshes shown, I can go up to File, Export to merge everything together as a single mesh. Bringing the mesh back into Artec Studio, I can see where some parts of the Ray and LEO data overlap that may not be best for reverse engineering. To work around this, we can go back to the meshes created from Ray Triangulation and erase the areas where the LEO data exists. This removes the lesser quality mesh from the higher quality LEO data when exporting everything all together. From here, we can bring this mesh into any other software we want to run some tests or reverse engineer. Working with Ray data is not much different than the other Artec scanners regarding the processing. We can quickly go from the point cloud of the Ray data to a complete mesh using some simple commands. We can also combine this Ray data with other scanners if we need higher quality mesh information in certain areas. Please subscribe to our channel for more information on Artec Studio, scanners, and other CAD softwares.